Our last objective is a distributive practice calculating percent yield given appropriate data. Percent yield is a measure of the efficiency of a reaction, where we take our actual yield, what we make in an experiment, set that over the theoretical yield, what we find from our stoichiometry problem, and express that as a percent. Actual over theoretical times 100 gives us our percent yield. The first question, heating an ore of antimony, Sb2S3, in the presence of iron, gives the element antimony an iron 2 sulfide. Sb2S3, an ore of antimony. In the presence of iron means to add iron. Sb2S3 plus Fe. Given the element antimony, so that's saying it produces Sb and iron 2 sulfide, Fes. Let's see if we can work to balance this equation. Heating an ore of antimony in the presence of iron gives elemental antimony and iron 2 sulfide. 2 Sb's on the left. Let's try a 2 in front of the product Sb. 3 sulfurs on the left. Let's place a 3 on the product side. And finally balance the irons. 1, 3, 2, 3 is our balanced equation. When 15 grams of our ore, the Sb2S3 is the antimony ore, reacts with an excess amount of iron, it produces 9.84 grams of antimony. This is what our actual yield is telling us. We didn't perform the lab, therefore we are being told what we made from the experiment. Let's measure the efficiency of this reaction by calculating its percent yield. Taking a look at Sb2S3 as the given, we want to compare our actual yield. We need to make the target grams of antimony. We want Sb given Sb2S3. We'll need a molar mass. The molar mass of antimony, it's number 51. We'll call that 121.8. 121.8 times 2 plus the sulfur, 32 times 3. This has a molar mass of 339.6 grams of Sb2S3. We'll place that under 1 mole of the ore, Sb2S3. The heart of our problem, we want over given. We want the antimony. See, that's our target. Its coefficient of a 2 gets placed on the top. Given 1 mole of Sb2S3, our want over given will be a 2/1 ratio. We will then need the molar mass of antimony. Again, I just looked up 121.8 grams of antimony in every 1 mole of the Sb. Let's hit 15 divided by 339.6 times 2/1 times 121.8. This gives me a value of 10.7, around 6 grams of antimony. This is what's known as our theoretical yield. Our actual yield was 9.84. Recall the formula? To calculate the efficiency of a reaction, we take actual over theoretical expressed as a percent. The actual given to us, 9.84 grams. The theoretical we calculated, 10.76 grams, expressed as a percent. We will hit 9.84 divided by 10.76 equal. When I express that as a percent, I get 91.45% yield, and that is the measure of the efficiency of my reaction, 91.45% yield.